Sometimes we get indeterminate forms that are infinity minus infinity. And when you do, remember, you're going to have to do some sort of manipulation. If I look at the limit as x approaches 1 from the right of this function, this is, of course, infinity minus infinity, and that's not very helpful. Remember, I need to get it in the form 0 over 0 or infinity over infinity. Well, now obviously I'm adding two fractions here. So let me get a common denominator. Let me look at the limit as x approaches 1 from the right of x minus 1 minus the natural log of x divided by the natural log of x times x minus 1. Well, if I just directly substitute in, that's going to give me 1 minus 0 divided by 0 times 0. So yeah, this is definitely indeterminate. So let me use L'Hopital from here. So I'm going to let f of x equal x minus 1 minus the natural log of x, and g of x equal the natural log of x times x minus 1. So f prime of x is 1 minus 1 over x. G prime of x is, now we're going to have to use product rule. So this one's going to get just a little bit messy, but that's all right. So this becomes, the derivative of log is 1 over x, okay, plus this derivative is just 1, so it'll be plus log of x. So my limit, f prime of x over g prime of x, and let me go on and do the limit there, forgot it. The limit as x approaches 1 of f prime over g prime is equal to the limit as x approaches 1 from the right of 1 minus 1 over x divided by x minus 1 over x plus the log of x. Now, if I look at this, this is an absolute mess because this does again become 0 over 0. So let me try rewriting. Let me extend my page here. So let me just get a common denominator. So this is the limit as x goes to 1 from the right, and I'm going to pull out a 1 over x in the numerator. So this is x minus 1 divided by, and pull over 1 over x in the denominator as well, because those will go away. X minus 1 plus x log x. All right, let me let those cancel. And this is the limit as x approaches 1 from the right of x minus 1 divided by x minus 1 plus x log x. Now, do we help ourselves out at all? No, this 0, this becomes 1 minus 1, which is 0, times 0. So again, we're in indeterminate form, but that's okay. Let's do L'Hopital one more time. So I'm going to let f equal x minus 1. Now, see, the beauty here is f prime of x is just 1. G of x is x minus 1 plus x log of x, so that g prime is 1. Now you need to use the product rule again, so this is going to be log of x plus x times 1 over x. All right, so g prime is 2 plus the natural log of x. Now we're getting somewhere. So the natural log as x approaches 1 from the right of f prime, and realize this is actually f double prime, this is green f prime, that's equal to 1 divided by 2, oops, I'm forgetting my limits today, it's equal to the limit as x approaches 1 from the right of 1 divided by 2 plus the natural log of x, or 1/2.